Cambridge AS Computer Science, a Chapter 2, Communication Part 1. This chapter is very interesting. This chapter has lots of information that is copied from the ICT O level and is also copied from the computer science O level. So this chapter is not very new. However, of course, there will be some additions because we are doing the AS. I will try to go through it a little bit fast, as you should all be familiar with what is in this topic, and let us collect information, and as soon as possible we pause to solve some past papers. So network, we are all living in the world of networks. The internet is around us anywhere, everywhere. And also, we are using instant messaging to send each other on WhatsApp. WhatsApp is a commercial name, and commercial names are not allowed. However, I use commercial names to help you understand what do I mean. Okay? So a network is two or more computers or other electronic devices connected together so they can exchange data. So when you connect, for example, you may connect your smartphone to your laptop computer to send a file, or maybe you use your smartphone as a hotspot and use your laptop to log into the internet through the hotspot. All of these are examples of networks. Network connection between computers are typically created using cables. In old days, networks were only created using cables. And we have different shapes and sizes and categories of networks. For example, we will be talking about a local area network in a small area. So typically that network will be connected using cables. However, in your homes now, you may have a network using Wi-Fi, and this is wireless. So in that case, we will call this wireless local area network. Sometimes radio signal, wireless or Wi-Fi, or telephone lines and modems. The internet reaches your home through a telephone line or a modem, because the modem is necessary to change the signaling between analog and digital and back and forth. Or sometimes fiber optics. Fiber optics, we will be studying all these media for data transmission in this chapter. Okay, so the fiber optic is a glass, is made of glass, and it transmits data as pulses of light. Definitely, this is much faster because it transmits data at the speed of light. Okay, and then satellite links. Maybe we will not talk a lot about satellite links. Maybe satellites are used now for GPS. Okay, okay. Or if you are in a rural area with no infrastructure, you would use the internet from the satellite, then it's going to be very expensive. Okay, so we have different shapes and different sizes of networks. Let's go directly to the syllabus. Types of network. We have local area network. A local area network is a network confined in a small geographic area, typically connected using cables. You should have an understanding what a hub or switch is or are. What a hub or switch is. It's a device that allow computers to connect together on a local area network. Okay, we will get to that. We will study the hub and the switch separately in few minutes, inshallah. Okay, so a local area network is a network confined in one building on site or site. Often a LAN is private, so typically it is owned by an organization. On contrast, the internet is not owned by a single organization. It's a collaboration between many organizations all over the world. Everyone is contributing with a server or a service. Okay, but a LAN is so small such that it is owned by an organization. Okay, often a LAN is private, belonging to our organization. Because LANs are geographically small, they usually use cables. We usually use cables, however, sometimes we use wireless. And then you may need to compare and contrast benefits and drawbacks between cables and Wi-Fi. We will get through that shortly, inshallah. Devices are connected over a small geographical area, uses dedicated company-owned infrastructure, cover a small geographic area. The infrastructure is privately owned, not controlled by external organizations. Looks like these bits of information are copied from mark schemes. Go and study these. These are bits of sentences copied from mark schemes. Okay? Okay. So these are in exams right now. Advantages of connecting to LAN. Allow sharing of file data, allow communication between devices, allow sharing of resources, hardware, software, and application, allow central management, for example, backup and security. So if also these, as you can see, these are just raw sentences from mark schemes. I'm exposing you to mark schemes in my notes. I think this is best. This is what I think. Okay, so you share files on a local area network. Instead of copying files on a flash memory and inserting it in every computer, you may have what is called a file server, and you allow file sharing, and you copy files from the network. Okay, and communication. Okay, sharing of resources, like for example a printer. You have a single printer that all the lab or all the department can print on it through the network. Central management, for example, all your data is on the file server, and you may back up the file server or apply security username and password on the file server, and this is called central management. You cannot have that features if you have standalone computers. Okay, advantages of LAN. Faster compared 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 to wireless. Okay, so what are the advantages of having a LAN? A LAN is a local area network connected using cables. Compared to wireless LAN, we call this WLAN, that will come soon. Okay, okay, as you can see, all of these are exam questions. I'm trying to expose you to exam questions and mark schemes as much and as soon as possible. So, okay, faster connection and higher bandwidth. This is when you are using cables instead of using wireless. More reliable and stable connection, because the Wi-Fi would not be that stable. When you go further away from the device, you may suffer from poor internet or slow connection or connection loss. Less susceptible to issues with distance and walls. Actually, these are all problems with Wi-Fi. Okay, more secure than wireless, because wireless signal may be intercepted by neighbors. Cables signals will not get outside cables. Okay, so as you can see, the topic about local area network has many questions that appeared in the past papers. Okay, now we go to another kind of network, that is wireless local area network. Being local area network means that it's in a small geographic area. Being wireless means that it uses radio signals instead of cables. And typically that kind of network will be Wi-Fi based. We have two wireless technologies, Wi-Fi and Bluetooth. We use Wi-Fi in networks. Bluetooth is much smaller and much slower and much simpler, cannot allow a network. cannot handle a network. Maybe Bluetooth will be used to connect a headset or a speaker to a device, and that's it. So wireless local area network WLAN, a wireless LAN is a LAN that uses radio signals Wi-Fi to connect computers instead of cables. Why? Because this provides flexibility. Definitely all your houses now have networks that are connected using Wi-Fi. Okay? At the center of the WLAN, so a wireless local area network, we call it WLAN, is a wireless access point. You have a bit of confusion here because at home you have a router, a box called router, and you connect to it Wi-Fi. This is not typically accurate. What I'm saying is not accurate. In that box, you have a router together with a switch, together with a wireless access point. So you connect your Wi-Fi to a wireless access point. And this is part of what's in the box. Okay, we collectively call that box router because this is some commercial or popular name for it. But inside of it, we have a router to connect your local area network to the wide area network, to the internet. You have a switch. We will come to that device switch right now. And then we will have a wireless access point that enables connection using Wi-Fi. So at the center of our LAN is a wireless access point connected to the switch. Most laptops have a wireless network. In your laptop, you have wireless network interface card. In your computer, typically you have a network interface card for connecting to a cabled LAN and another wireless network interface card to connect to a wireless local area network using Wi-Fi. Okay? WLAN uses wireless technology to transmit data. Okay? Advantages of WLAN. Definitely compared to a LAN. So here, advantage of LAN compared to WLAN. Okay? Okay? So freedom of movement. When you have wireless, you enjoy the freedom of movement. Okay, freedom of movement, as users can move between different rooms with a mobile device and still receive and transmit data. No need of a physical connection or cable. Easily expanded if a new user wants to access the network. Less cabling and less expertise are needed, making the initial setup less expensive. So wireless is more flexible, is easier to set up, reduces the cost of installing wires. However, disadvantages of wireless are just here the advantages of wired. Okay, so slower connection, lower bandwidth, less reliable, less stable connection, more susceptible to issues with distance, less secure, the more secure, less. So wireless, okay, I can get these into here and mention them as disadvantage. Okay, next we come to wide area network. A wide area network WAN. A wide area network WAN is a network that covers a large geographic area. And this is a network that covers, for example, the internet. And this is, for example, the internet. So a wide area network WAN is a network that extends over a large area. The internet is an example of a WAN. A WAN is often created by joining several LANs together. So in this diagram, you can see that this is a local area network LAN, and in the middle, you have a switch. And the switch is connecting all computers together using cables. And then you take a cable from that switch to the router. And the router goes to that big cloud. That big cloud represents the WAN, the wide area network. Okay. And also here you have another local area network, another local area network, another local area network where you can join them all together where data may go freely between networks. Okay? So a wide area network is a network that extends over a large area. The internet is an example of a WAN. A WAN is often created by joining several LANs together. Because WANs are geographically spread, links are over long distance. We often use technologies such as optical fiber. These are glass cables. Glass cables. Okay, satellite radio links, microwave radio links, etc. Okay, advantages of WAN: cover large geographic area. Okay, comparison between a LAN and a WAN, comparison between a local area network and a wide area network. WAN cover large geographic area and LAN cover a small geographic area. LAN connection between devices are usually physical. So you connect devices in a local area network using wires. Okay, whereas WAN connections are often virtual. So you virtually connect to, for example, a server like Amazon, because your connection goes through many stages and many intermediate routers. So you are not physically connected, you are virtually connected. Okay, LAN has higher transfer data rate. Data goes through a LAN faster than it goes through a WAN, because a LAN is in your house and cables and switches that are much faster than routers, for example, reaching a server in the US or a foreign country. Whereas WAN has lower transfer rate. So definitely data goes faster through the LAN than it goes through a WAN. The ownership of a LAN is private because it is a small network, so it is private. The ownership of a LAN, of a WAN, can be public. Okay? You may have a WAN. Not all wide area networks are just the internet. You may have private wide area network. For example, a bank with many branches may wish to have his own private wide area network. LAN is more secure. A local area network is more secure because it's in your under your own ownership. Okay, okay. Than a WAN, because protection is easier to implement. Okay, so definitely that was an exam question discussing local area network and wide area network. Let us go now to the classified and have a look at how questions show. So please go to my classified page 61. This is the beginning of chapter 2, communication, and this question is from 21 November, paper 1-1. It says a school is setting up a network within one building. State whether this network will be a LAN or a WAN. Justify your choice. So the answer should be a local area network because it is within one building. However, the question is asking you for justification. So the answer is LAN. The justification, because it is a small geographic area, because no leasing. You have your own, so it is owned by the school. It is one building. That building is owned by the school. Cables inside that building will be owned by the school. And these are the tip features of a typical local area network. Okay? Does not use internet to transmit within the building. You only need your own cables, or at most you can make it wireless. Okay? So the answer is local area network because it is a small geographic area and the infrastructure is totally owned by the business. Okay? Let me go through other topics you haven't studied yet. Okay? One classroom in the building has 30 computers. The computers need to be connected to the network. Each computer has a network interface card. Okay, identify two possible devices that can be used to physically connect the 30 computers to the rest of the network. You need a switch or a hub. You may also need a router. Actually, I didn't explicitly discuss that with you because questions, they are mixed together. Okay, so two possible devices to connect two possible devices to connect computers. You typically use a hub or a switch. If you also want to mention a router, that would be fine. Okay, that question you should be able to answer. The school have several laptops. Each laptop has a wireless network interface card. Describe the functions of a wireless network interface card. So, the wireless network interface card provides an interface to the wireless network as an antenna for sending and receiving radio signals. Receives analog radio waves, convert them into digital binary. Check incoming transmission for the correct IP address of that device. Ignore transmission not intended for it. Encrypts data, decrypts data, takes digital binary input and convert to analog waves, send the radio waves via the antenna. Okay, so the wireless network interface card provides an interface to the wireless network through an antenna. The antenna is the aerial that transmits and receives radio signal. Also, it converts digital data into analog radio wave signals. Also convert the received analog radio wave signals into digital data so that it can communicate with the wireless access point. Okay, let us get back to our discussion because we need to cover many topics before we can do past papers. Okay, so that was a bit about types of network: local area network, wide area network, and wireless local area network. We come to a new topic called network topologies. Okay, let us study various network topologies for connecting computers together. Topology is the configuration of the network that defines how various devices on the network are connected. Let us go through examples so that you can understand what we are talking about. This is just a computer with another computer and we connect them together. This is very simple. We call this point to point. This is very simple. We will not pay much attention to it. First, we talk about bus topology. And that topology was used very long time ago. Right now is not used at all. We call that obsolete. Why do we have to study obsolete technologies? Maybe because we have to appreciate benefits of modern technologies. This is the modern technology used right now, or topology. So this is the topology used right now. We call it a star network. Let us go to that previous diagram. This is a network, local area network, with a hub or switch in the middle. And every computer has its own cable connecting it to the central device in the middle, that is the hub or the switch. Okay, we call this star topology. It looks like a star, even if it doesn't look. The typical feature of a star topology is that every computer has its own link to the central device. Each computer has its own link to the central device. Okay, we call this star topology. Okay, On the opposite side, we have a bus topology. With a bus topology, you have a single cable that is connecting all these computers together. That is so much old. We don't use it right now. I don't know why do we have to study it, but it is in the syllabus. I cannot skip it. This is called bus topology. It has lots of problems. For example, it may result in collisions. We have to study collisions also. Collisions occur when you have a bus topology. Why? Because you have a single medium for connecting all computers together. And for instance, if that computer transmits data, at the time another computer is transmitting data along a single shared medium, data will interfere with each other and will become corrupted. We call this collision. Actually, there is nothing to collide, but transmitting two signals on the same medium would corrupt each other, and both of them will not be distinguished. And I call this collision, or the syllabus calls this collision. So collisions happen only with a line topology. Collisions happen with a line topology like this. This is bus topology. Bus topology contains one shared link to which all devices are attached. Benefits of using bus: easier to set up and extend, less cables are required. However, if the main cable breaks, network performance will be badly degraded. Difficult to detect and troubleshoot faults at an individual station. Efficiency reduces as the number of devices connecting to it increases. Collisions occur. This is what I have been saying. This is the topic or the problem of having collisions. Okay? When a computer transmits, whilst another computer is transmitting. And we have to study how to mitigate this. Okay? Okay, so collisions occur, so not suitable for network with heavy traffic. Security is lower because all computers listen to all communication. Several computers receive the signal from the source. Okay, okay. What else? We have mesh topology. Mesh topology, we have what is called fully connected mesh topology. Okay, with fully connected mesh topology, all computers are connected to each other computer using its own cable. So this computer is connected to all other computer using cable. This computer is connected to every other computer using cable. And this makes the number of cables increases very, very, very high. So a fully connected mesh topology, each computer has a point-to-point connection to each other computers. Mesh topology contains direct links between devices. This is very expensive. We have now what is called partially mesh. Partial, where computers are connected to several other computers, but not necessarily all. And this is typical now on the internet. All computers are connected to at least one other device. This is partial mesh, not fully connected mesh. There are multiple routes between devices. This is not a full mesh. However, it helps a lot. Computer can act as relays, passing packets on towards. This is a typical layout for the internet. Okay? Okay. So what are the advantages of having mesh topology over bus topology? It looks like this is a question in the past paper. When you have mesh topology, if one link goes down, there are more routes available. This is better than that. Okay, the computer, okay. All nodes can be added. New nodes can be added without interruption. Here you may have interruption. Okay. Improve security as not using one main line. More secure because data is sent over a dedicated connection. Okay. Okay. So that is a mesh topology, and this topology is typically used through the internet. This is fully connected mesh, and it is very odd now because it is very expensive. Okay. Now we come to the most popularly used topology in a local area network, and this is what is called star topology. This is a star. Okay. How can you tell that this is a star? Because every computer is connected to a central device using a dedicated cable. Okay, in star topology, each computer has point-to-point connection to the central device, and that device will be the switch or the hub. Okay, benefits of using star topology. You have to go and study all these comparisons because these are the discussions that appear in the final exam. Benefit of using star topology like this. Signal only go to the destination only, so more secure. Instead, that signal here goes to all other computers. Easy to connect and remove nodes and troubleshoot. Centralized management helps in monitoring the network. Failure of one node or link doesn't affect the rest of the network. Performance does not degrade under load, fewer collisions, or I may say no collisions. With star topology, you may not suffer from collision at all because there is a dedicated line between this computer and the central device. And there is another dedicated line between the central device and the other computer. Probably there will be no collisions at all because everyone has his own or its own, every computer has its own case. Drawbacks: if the central device fails, the whole network goes down. You are fully dependent on that central device. Performance is dependent on the capacity of the central device. Again, you depend on the performance of the central device. Next, we have what is called hybrid topology, which is a mix between two or more topologies. As you can see, you have here a star, you have here a bus, and this is called ring, but we don't have to study it. A hybrid topology is a type of network topology that uses two or more different network topologies. These topologies can include a mix of bus topology, mesh topology, and star topology. Okay, what else? The Ethernet. The Ethernet is the dominant technology used for local area network. This is the protocol used with local area network. Ethernet was implemented on a LAN configuration or using a bus or a star with a hub at the center. The hub has a problem. The hub has a problem that it sends the received data to all other computers. And this may cause collision. Okay, the star is intelligent. The star, we have here a hub or a switch. I'm sorry. We have here a hub or a switch. The hub is dumb. It receives a data and send it to all other computers. The switch is smart. It receives a data packet intended for a certain recipient, and it forwards this only to the required recipient. So the switch will not cause collisions. The hub may cause collisions. Okay, so the Ethernet, okay, the Ethernet use broadcast. The hub uses broadcast. Okay, So all the Ethernet that uses bus or star, they use broadcast where data is sent to all computers, and the computer interested in the data would accept it. Other computers would ignore it. This is very old and not so useful. Modern implementation use a switch. The star configuration has a switch as the central device. The switch controls transmission to specific computer. Each computer is connected to the switch by a full duplex link, so no collision is possible along that link. Since collisions are now impossible, CSMA-CD is no longer needed. What is that? This is what we will be studying about how to mitigate collisions. Okay? So, in Ethernet with a bus or hub, you need CSMA. In an Ethernet with a switch, you don't need CSMA-CD because collisions will never occur. Okay? Okay, what is the meaning of Ethernet? Ethernet is a protocol suite for data transmission over standard universal wired cable. Okay, it uses carrier sensing multiple access. So this is for collision mitigation. Data is transmitted in frames, and each frame has a source and destination IP or MAC address. Okay, MAC address. It uses error checking data so damaged frames can be reset. And this is definitely an answer to a question in the exam. So it asks, what is the meaning of Ethernet? Ethernet is a protocol suite for data transmission over standard universal wired cable network connection. Okay, it may use CSMA-CD. It may use this to avoid collisions. Okay, so I just say it may use, because sometimes it's no longer necessary. Okay, when an Ethernet is built on a switch, this is no longer necessary. But when the Ethernet is built on a bus or a star with a hub, this is necessary. It may use carrier sensing, multiple access, collision detection for mitigating collisions. Data is transmitted in frame, and each frame has a source and destination MAC address. It uses error checking so damaged frames can be reset. And that was an answer to a question about the meaning of Ethernet. Okay, so Ethernet is a local area network. Let us study this. Description and type of LAN. We have bus with terminator at each end. We have a star. We also have wireless. Okay, so any packet the listening computer receives may be part of a message for that computer. This is in a bus with terminator at each end because it is broadcast. And this is also with wireless because wireless signals go through the air as broadcast. Okay. Connection provided through an access point. This is only in the wireless. A process of hand collision has to be implemented of handling collision. This is in a bus with terminator on each end, and this is with wireless. Listening computer only receive packets that are addressed to this computer. This is just the star. Let us go to page 65 in my classified, because actually using the topics we have covered, actually I cannot find complete questions that we may answer. However, let us have a look at questions and how they show in exams. So for example, in this question is taken from 22 November paper 1-2, and this is very recent. Okay, a local area network LAN consists of 4 computers, 1 server, and a switch. This is a server. This is the switch. The LAN uses a star topology. Complete the following diagram to show how the hardware is connected. So here you have a switch, and the switch is directly connected to the server. We need to draw. I think I can draw. So, because you have a star topology, and this is the switch, I think you need to draw a line connecting this computer to the switch, connecting that computer to the switch, and the server is fully connected to the switch, and also connect that computer to the switch and connect that computer to the switch. I think this is what you need to draw to get the marks, because it is star topology. So the switch is at the heart of the network, and every computer has a dedicated connection to the switch. The server has full duplex connection to the switch, and also all computers have full duplex connection to the switch. Okay, so please draw this. Okay. Next, a router. We didn't study the router yet. Okay. A router is attached to one of the devices on the LAN shown to connect the LAN to the internet. Identify the device. Give reason for your choice. I think the router will be connected to the server. Server provides the request and authorizes traffic. It has a firewall on the server. Or you may say the router will connect to the switch. The switch is connected to all computers to share access to the router on the network. So I would preferably say that the router will be connected to the switch. If the router will be connected to the switch, all computers will have open access to the internet. If the router is connected to the server, all computers need to be authorized by the server before being connected to the internet, and this will implement security. Okay, connect the router to the switch. It doesn't matter. Then describe the role and function of the router in the network. Let us study it here. Receive packet from the internet. Find destination of packet using the IP address. Forwards packet to the destination. Sign private IP address to device. Assign. Okay, lots of details we haven't studied yet. Store, update a routing table. Okay, this is too complex. We haven't been through the router yet. Let's keep it for later. Okay. Let us, again, a question about a router. Okay, let us go back and study, because I cannot hear about carrier sense multiple access. Because this question is very recent. Let us go and study carrier sense multiple access collision detection, CSMA-CD, that is used in a bus network to mitigate collisions. Okay, let us go back to our study. What is collision? A collision, two messages sent at the same time would collide, and each message would be corrupted. The method adopted to avoid collision is CSMA-CD, and this is abbreviated carrier. This is the abbreviation of carrier sense multiple access with collision detection. Okay, So you have to study this word very carefully because you can see it's on the exam. What is collision detection and avoidance? We can, let me explain it first before we go and read. We have to put some rules. For example, this computer is transmitting data and this computer wants to transmit data. The first rule is before you attempt to transmit data, listen to the channel. If somebody else is transmitting, just wait. This is what is meant by carrier sensing. Just listen and see if somebody is transmitting before you. Just wait until that other computer finishes. This is what is called carrier sensing. Okay? Okay, this is half of the solution. The other half is that nobody is transmitting, and it happens that this one and that one, they attempt to start both at the same time. Okay? They both checked and the channel is free. And then it happened that they both started at the same time. Again, collision will occur. So what is the solution? There is something called collision detection. It detects that some interference is happening. So the solution will be both of them will halt, both of them will stop transmission, both of them will wait a random amount of time, and then attempt to transmit again. So in the first place, they check that the channel is free. If the channel is not free, they never transmit. Secondly, if the channel is free, it may happen that two devices attempt to start transmitting at the same time. In that time, inevitably, collision will occur. So when a collision is detected, it's both of them halt because the signal is corrupted for both of them. Both of them halt, wait a random amount of time, and then attempt to transmit again. This is what is called by collision detection and avoidance. You have to study it very well because, as you can see, it's on exams. So it is called carrier sensing multiple access with collision detection, abbreviated CSMA/CD. This is the LAN access method used in the Ethernet. Okay, this is the LAN access method used in the Ethernet. When a device wants to gain access to the network, it checks to see if the network is free. If it is not free, the device waits a random amount of time before retrying. Computer listen to the communication channel. If no data is being transmitted, the computer can send. Collision is caused when two devices transmit at the same time. If collision occur, each computer stops transmitting, waiting a random amount of time before retransmitting. Each time a collision occurs, the random time is increased. Okay? Okay, tasks performed by CSMA. Maybe this is the question, the answer to that. Okay, describe how carrier sensing multiple action is used in a bus network. Okay, see, this is a direct question in 22 November paper 1-1. We will get to it immediately. Task performed by CSMA-CD. Only allow data to be sent when the link is idle. Detects a collision on the network, halts transmission when a collision occurs, calculates a random wait time, allow retransmission after random amount of time. Okay? Okay, again, with star topology using a switch. As a star topology is created, the switch has number of ports and each connects to a single device using a dedicated cable. This is a switch. This is here the server. This is the switch, and all computers is connected to the switch using dedicated cables. The switch provides a direct transmission path from a device to a device. Collisions are no longer possible. Okay, so collisions with the star topology using a switch will not happen. There are dedicated links from computer A to and computer C through the switch, and from the server to computer D through the switch. Collisions will not happen. Let us read this. All packets must be routed via the server. False. All packets must be routed via the switch. Computer B can read a copy of the packet sent from server to A. This is false. Computer B cannot read. Why? Because there are dedicated links from A to C through the switch and from the server to D through the switch. No collisions are possible. This is true. Okay? So as you can see, these are the discussions about switch and local area network and collisions and that kind of things. Okay, let us go and see what can we do with questions. Okay, what can we do? Let us do this. Let us do this. A local area network LAN uses a bus topology. So it's not a star. It is a bus where collisions occur. Describe how carrier sensing multiple access collision detection is used in a bus network. This is a very direct question about what we have been saying. Let us read it carefully, because when you see a question about my discussion, you think that my discussion is important. Okay, that question was on 22 November, so it is just the latest session, just the previous session. It says a local area network uses a bus. So this is a local area network using a bus. This is a local area network using a bus. Okay? Using a local area network with a bus, collisions occur. What is collisions? A computer starts transmitting when another computer is transmitting. Data collides. There is no collision here. However, data interfere with each other and data is lost. Okay? So, when a computer starts transmitting, while another computer is transmitting, data will interfere, data will be corrupted. We call this collision. Okay, there is also another problem, that there is nobody is sending and both of them they attempt to send at the same time. Again, this will result in data collision. So there is a protocol called carrier sensing. What is carrier sensing? Before you transmit, you listen. If somebody else is transmitting, do not transmit. This is called carrier sensing. Multiple access, because all of them are sharing the same cable. Okay, with collision detection. If collisions occur, devices will detect that, halt transmission, wait a random amount of time, and then attempt to retransmit again. So the question says, describe how carrier sensing means before you transmit, you listen to the channel. If somebody else is transmitting, wait. Okay? Multiple access because everyone is sharing a single bus. Collision detection means if collisions occur, devices halt and wait a random amount of time before attempting to retransmit again. This is very necessary in bus network because collisions occur. because we have a shared medium. So you should write 4 points. This is the mark scheme. CSMA-CD is a protocol used to detect and prevent collisions in bus topology. Before transmitting, a device checks if the channel is busy. If the channel is busy, the device waits. If the channel is free, the data is sent. Because there is more than one computer connected to the same transmission media, two workstations can start to transmit at the same time, causing a collision. If a collision is detected by the device, transmission is aborted, a jamming signal is transmitted. Both devices wait a different random time and then try again. This is the best explanation for CSMA-CD. Please copy it. Copy it to your classified and be ready to answer these kind of questions, because as you can see, they are showing in exams. Please give yourself time and copy it. Let us do another question. And if some devices we didn't cover much in details show, we will just explain it. So this is page 63 of BiClassified. Okay. The following incomplete table contains 4 network devices and their descriptions. Complete the table by writing the missing devices and missing description. Receives and sends data between two networks operating on the same protocol. This is the router. So the router connects different networks together using the same protocol. We will come to that discussion later, but I just need to have a look at what questions say. Okay, so just write here a router. Okay, you may have some knowledge about the router from the O level, and now here I am completing your information. And then you need to write the description of wireless network interface card, WINC. Describe it. It's a hardware component that allows a device to connect to a wireless network, because it's a wireless network interface card. Provide a MAC address to the device to identify it on the wireless network. Each wireless network interface card will have its own different unique MAC address to be identified on the network. Okay. Restore the digital signal so it can be transmitted over greater distance. This is a repeater. When the cable length is so long, after a long distance, the signal will degrade. We need a repeater to boost the signal to its original strength so that it can be received. So restore the digital signal so it can be transmitted over greater distance. What is a wireless network? What is a wireless access point? Hardware component that provides radio communication for the central device to nodes on the network. So this is a wireless access point. Okay, I'm sorry that all of these, especially fiber optic. Okay, 3 differences between fiber. Fiber is made of glass compared to copper. Copper is made of metal conductor. Okay, all these will be explained the next session, inshallah, because I'm stopping here at transmission media cable, coaxial fiber, okay, and wireless. We will come to that soon. However, let us read the mark scheme for this. Describe 3 differences between fiber optic cables and copper cables. Okay. Fiber optic data is transmitted using light. Copper cable through electrical signal. Fiber has higher bandwidth than copper. Fiber optic has higher transmission rate than copper. Fiber optic has a smaller risk of noise interference than copper. Fiber optic can be used over longer distance than copper before repeaters are needed. Fiber optic is much more difficult to hack into than copper. Fiber optic is more prone to damage. You may break it because it's a wire of glass, more prone to damage than copper cable. Okay, that was an introduction to what we will say next session when we continue our discussion using about this chapter, communication. I hope everything is clear, and please study carefully and do all the classified questions so you get an understanding of how questions will show. Thank you very much for your attention till now.